So in this session, we will be designing APIs using OpenAPI. So this will be a good um, concept review if you are into open APIs, and if you are doing the um, coding session, video number 7, where we refactor the backend code for uh, into an open API enabled backend. You will see what are the options that we will be using. So the objectives of this video is as follows. Of course, it's only one. It's just create and design a predictable API using Open API standard or configuration. So let's go to the example of building the to-do app, or for this case, the backend. So we would need create a to-do, list all to-dos, get one to-do, update one to-do, and delete one to-do. And each to-do has the properties of the title of the to-do, the description, and if it is done. So in this case, we would have something like this in our code. So we will be using Fastify um, for this example, but it would also be equal to Express. So let's say we have this path given the API prefix and slash to do. We would usually have the function, which is the logic of that code here. And this is the method. So let's use a pointer. So this is the method, this is the path, and this is the function. For this function, you'll get the body from the request and get the parameters or properties from that body. Then maybe do something here and return the results. As for getting the API, we would have again the getting the to do. We would have the get method, the path, and maybe the function itself. Because it's a get method, we are not expecting anything from the body. But if you need to pass values, you'll use the query parameters, which is done as like this. You'll have, after the question mark, you have a key value pair separated by the ampersand or the end character. And then given there, you'll get the limit and the after date given these two variables. And then the next would be we get the parameters from this usually is if we want to get one item only. So given let's say this character or this pattern where you have a colon sign and an ID, you are defining that whatever string that is being put here will be the value for the ID. Um, and let's say if we want to update, we can use put as the method. And again, we can get the ID to determine what will be the ID of the to-do that we want to update, and update the title, text, or is done. And lastly is delete. So given these code systems, how do we transform them into Open API? How do we design APIs to be predictable? So one is to use Open API. Open API is an initiative by several um, developers to make sure that when it comes to designing APIs, it is predictable, so that developers have an easier way of communicating with each other in terms of the code that they are implementing. So the first things that we will discuss is how is the specification for OpenAPI is structured. So there is a main specification structure, which is the minimum setup is you have the OpenAPI, you have info, paths, components, security, and tags. So the OpenAPI, which version of the API is being used? So we are using 3.0.0. If you have seen on the previous slides, the current latest version is 3.1.0, but in our code base we will use 3.0.0. This is the info, which describes what the API spec is about. And then a path, which is a key value pair dictionary list of paths that your API is serving. So we will discuss it later. The components are objects that are reusable, the schemas, the request bodies, parameters, security schemes, and responses that can be used by components and paths. And then a list of security that is described on security schemes that will be used in the project. And lastly is the tags. Now, for the info, the minimum setup would have you need to have a title and a version, which the version follows the semantic versioning setup, which is x.y.z, which means major, minor, patch. So if you are going to update your system, you can communicate with the people who are using your system that maybe you have a minor upgrade or a major upgrade or a patch upgrade. So usually if it's um, patch, a bump in the patch. So like if you started with 0.0.1 and then that means 0.0.2, that means you have added some code that is considered a fix of the bugs that is existing on the 0.0.z or the major version of that system. If it's a minor, that means you have added features, but uh, it is not major or it is not breaking change. It doesn't have any breaking changes. So a major would mean that there is a breaking change on your change of code. So usually if you have 0 as the number of the major, that means it's not yet in production, or it's not it usually is a beta version, alpha or beta version. But once it hits 1.0.0, that means your code is version 1 or the production version, meaning it has been tested and all of the features are there to make it work in essence. And then if you move that major number into, let's say, 2.0, that means a change in the behavior of the system, and there might be some incompatibility with the previous version. So that is some things on versioning. So the next is paths. The paths object will look like this. You have your paths, and it is the value would be an object. So each key of the paths would be, of course, the path name of where the resource would be put. So if you put slash, if we call slash, then any method inside that object will be activated. So one example would be given, let's say, to do. If we want to have the ability to get one to do item, you have a get method. You can also have a put method to update that to do, and delete method to delete that to do. And each method would have a object that has the following parameters. You have a summary, which is the short description of the path plus method, the operation ID, which describes what would be the operation logic function name to process that request. And then the parameters, which is the list of maybe path parameters, query parameters, or headers that we will need to pass values. And we can see it on the reference on uh, the parameters for this in the component section. Um, The request body is, of course, a dictionary list of types of request bodies that will be accepted. And then the responses is a dictionary list of HTTP codes that will be the response for each of the path method. And then the security is a list of security logic that this path plus method will pass through before accessing this path plus method. So a setup for the path responses would look like this. Again, you have your key value pairs. The key is the HTTP code that will be the response, and then the object is a response object, which which we can reference from the components, the C response section. And then security would look like this. You'll have a an array of objects. Uh, so the object would have a key, like for this one, better auth. That means it uses the better auth security function. Um, and if you don't have a key, that means there's no security that is needed for the, let's say, for the get method of the to do slash to do ID. If there is a string inside the array of, let's say, of the given security, it usually means scope, but we will not cover it. We will not cover scoping of security in this session. So for the components, the components on the main structure or schema would be this. You have a list of schemas, you have a list of parameters, request bodies, responses, and security schemes. Now, again, use components to make sure that you can create reusable components. We will do that on our video 7 on the building of the to-do app. So for the schemas, it's a dictionary list of object schemas that can be reused in all parts. And then parameters, a dictionary list of parameters that can be reused by paths only. And then the request bodies is a dictionary list of request bodies that can be reused by paths. The thing is, you'll need to put the $ref property if you want to use these reusable objects. And we will have an example later. Responses is a dictionary list of responses that can be used by the path, and security schemes is a dictionary list of security functionalities or functions that can be used by a path. So the key name should be the same as the key in the security array. So a setup for schemas would be like this. For this example, you have schema string, schema number, which is an ID, schema boolean, which is an ID, schema object. You can see here the $ref sign and how it is being used. So that means the object that is defined by schema object has a set of properties named prop1, and the prop1 uses the same definition as schema string. So that is what it means here. And then for array, schema array, the items in the array is a schema object. So that is what it means. So again, each key is a unique ID that can be referenced by this pattern using for component schemas. And the type is of course, the variable type that will be used for determining what data type is being saved on that property. So it can be a string, number, boolean, object, and array. Now the properties is a dictionary list of properties if the type is object, and items is the schema definition of the elements if type is array. Now for parameters, you'll have this setup. You'll need a name. Okay, so if you want to use the parameters, you use hashtag components parameters and the ID. Now you'll need a name, the name of the variable that will be accessed. You have in to determine where in the request is it being where you can access it. So if it's in the query, that will be after the question mark of the path. If it's in the header, of course, that is the request header. If it's in the path, that is like the slash to do slash colon to do ID. So after the colon, and cookie if you want to put the variable in the cookie um, session cookie. And then there's the description, a brief description of the parameter and if it's required. Now the thing is, you might heard it first, the cookie. Cookies are uh, a sort of breadcrumbs or a way to determine if you are, it's a tool. Actually, it's a tool for sessions. So in in web systems, usually the server doesn't really know, even if it doesn't really know who you are, even if you are authorized. And the only way they are able to know it is via session cookies. And in essence here, you can determine if what values can you put on the cookie. There are two types of cookies as well. And we will not be using cookie parameters here, um, because we are not going to add values on the cookies. But we will be using session cookies as a way to determine if you are authorized or not, and it is automatically set up by the system. Again, there are two types of cookies. One is HTTP only. That means it cannot be accessed in, let's say, your JavaScript, but it is accessible by the browser, but it cannot be manipulated on the JavaScript part on the front end, making it a little bit secure, especially if you are putting in tokens there, which we'll be using later on. And then the other is if you want to have the cookie being accessed by your front end um, system. So we will not be using that one. We will be using HTTP only, and you will see it on the next on video 8 of the session where we will um, create the authorization setup, log in, register, and so on and so forth. So um, on the request bodies, it will look like this. You have your ID again. To be able to reference that, you use hashtag components request bodies and then the ID. And then you'll need to have a description which describes the request body. Required if it is if this body is required, and then the content, which is a dictionary list of content types. As you can see here, if it's an application JSON, you'll have a schema, and then the schema can use or reference the schemas in the schema component, and so on and so forth. For the responses, it will also be the same. um, you have you What is different is it doesn't have the required, because this will be a response. So you have a description and the content. Now for security schemes, you have again each key as a unique ID that can be referenced by using the key and the security list. So maybe it's a bearer auth or a cookie auth, which will be used on the security array of each path, and as well as um, the main schema. And then each security function would have a type. Oops. We have would have a type: API key, HTTP, mutual, ITLS, OAuth 2, and OpenID Connect. So we will be using mostly API keys. And then there's the description of the body, which is if it's required. And then, oops, I should change this. Uh, okay. So there's the description, which describes the security scheme. The name, which is the name of the variable that will be use to access the token for the security, if it's header query or parameter. Even, I mean, the name of the variable that can be found on the header query or parameter. And to be able to do that, we can check it in the in. So if we have the in, where the variable will be found used when the type is API key. If the type is API key and you want to access the variable of the security scheme on the query, you have a value of in query and then the name of the variable. So that is the setup here. So that's it. That's the whole designing APIs for using OpenAPI. Um, for this setup, you may watch video 7 to be able to see how we transform the backend, which is using the usual Express or Fastify setup into an Open API setup.